a local maximum, the y-values of nearby points are smaller. So you can informally think of a local maximum as a peak in the graph. At a local minimum, the y-values of nearby points are larger. So you can think of a local minimum as a dip in the graph. A function changes from increasing to decreasing, or vice versa, from decreasing to increasing, at local maxima or minima. Maxima is plural of maximum. Minima is plural of minimum. A maximum or a minimum is a y-value, and it is located at an x value. A maximum or minimum is not an ordered pair. So if we look at this example, if I start at the leftmost point in this graph, negative infinity, and I start to trace, my graph is decreasing, it's falling, until I hit this dip in the graph, negative 1, 1. At this point it changes to increasing. This dip is called a local minimum. So this is a local, and we abbreviate min for minimum. So at this minimum, the graph changes, it starts to increase. It increases until it hits this peak in the graph at 1, 2. So this graph has a peak, or a local max, at 2. So local max is 2. Then as you move to the right from the max, this graph falls, it decreases until we hit the point 3, 0. Excuse me. This dip in the graph is another local minimum or local min. So this graph, because we know this point would be 3, 0, it has a local min of 0. So we can describe this graph and we can say it has a local minimum, or min for short, that is equal to 1. So the y-value at this dip is 1. And it's located at the x-value, negative 1. We can say then it has a local max of 2, because here this peak happens at a y-value of 2, and it's located at x equal to 1, because this x value is 1. And then we can say finally it has another local minimum, a local min, and it's equal to 0, and it's located at the x value of 3. So it's important to remember that a max or a min is not an ordered pair. So we didn't say that this graph, the local min is negative 1, 1. We say the local min is 1. It's the y value, and we describe its location with its x value.